In the last video, we defined this whole family of classes to represent different shapes. And at the very top of the hierarchy, we had this class that was just called shape. And the idea was we wanted to define some common ancestor of every class in the hierarchy, and we could embellish the hierarchy further. We can add triangles and things, and an ellipse or something similar to that. There's all sorts of interesting shapes we could add. We want one class at the very top that represents sort of the basic behavior we expect from all shapes. I guess the shape has a name. It can tell us its area, its height, and its width. So we define this class called shape, and it defines virtual functions that can be overridden by the subclasses to then define what that behavior means. The problem is the class shape is sort of weird. Its job is to provide an abstraction, so that if I hand you something of type shape, you know that you can get the area, the height, or the width, to be a point of convergence, to be a common ancestor. But it really isn't supposed to exist on its own. There will be lots of things in your program that are shapes, like a square or a rectangle, but you should never create a variable of type just shape, because it's sort of incomplete. A shape, a generic shape, doesn't really mean anything, unlike a rectangle or a circle. So the question is, what do we do? And the first thing I want to illustrate is I think it's very reasonable that we'd want a situation like this. Often we want to define a class whose job it is just to define an abstraction. So I hand you something of type shape, you know what to expect. You can get the area, you can get the height, you can get the width. But in a sense, the shape class is just an abstraction. It provides a little bit of behavior, so it's got a constructor. It does have a bit of code in it, but it doesn't provide everything. There is some stuff that the shape class just can't do for us. It's there to provide an abstraction, and it can't really implement it, maybe not at all, but certainly not fully. We actually call this a situation where we have what's called, I think, a good name for it is an abstract class. It's a class whose job it is to provide or help flesh out an abstraction, but it doesn't implement that abstraction. It depends on subclasses to do that. And so this video involves different ways of solving one problem, which is if I know that the shape class isn't ready for prime time, if I know that it's incomplete, how do I prevent people from trying to create instances of it? And as usual, we shouldn't need to learn a new feature if stuff we already know does the trick. So I want to first show off a way we can do it using a technique we already understand. But I think I can prove the point that that technique is a bit clunky. It requires quite a bit of admin, and we have to be very careful. And therefore, there is a nice convenient feature that's not too hard to learn that makes it a lot easier, and also is a bit more prescriptive. It doesn't just impose restrictions, it gives a hint to other programmers what they need to do. It helps to write them a list of things to do. So I'll begin by compiling this, and I'll show off that this attempt on line 157 to make an object of type shape succeeds. So I'll run it. And if we scroll through this big mess, we can see after all the print calls, there is a constructor for a shape. The shape object also has this second constructor that lets you give the shape a name. So I'll give the shape a ridiculous name to try and prove the point that I, a member of the general public, should not be allowed to go constructing generic shapes. And so here I call the other shape constructor. I guess I should try and print the shape out after I do that to show off the stupid name that I've made up. So we'll try printing the shape out. And I go and I notice this call to print a shape that has no meaning whatsoever, because I shouldn't be allowed to create this generic shape myself. And so the task for the video is, let's see what we can do to prevent this from happening. So there are a couple of things. When I say prevent it, to be clear, I want a compile error. I want the compiler to prevent me. There are ways I could prevent this at runtime with exceptions or things, but that would be a bit sloppy. I want the compiler to prevent me from trying this. I don't want to think that the program's going to work with this in it. So I want the compiler to prevent me. So how do I prevent anybody from creating an object of type shape? Well, we know already that the object, when I define a class, the class can exercise complete authority over who can create the object. And it does this via access control. That's the technique we already know. So I want the result of this video to be getting some compile errors. For once, I want to actually create compile errors. So here's one option. What I could do is I could make the constructors private. If I do this, as we know, because creating an object requires constructing it, I'm not allowed to construct objects if the constructors are private. So we'll try that. I want an error on line number, I want line number 158 to be an error. And I look at I didn't save it. Well, that was a bit anticlimactic. We'll try it again. Okay, there's an error, and sure enough, line 158 gives me a compile error. That looks good. That means you can't create generic shapes. And let's verify that that's the only problem, because obviously I want this to be an error, but I want the rest of the code to still work. And it doesn't. And if we stare at it, we'll scrub through it and notice that it's generating a lot of very similar complaints. But notice how it seems to be complaining about the constructor for, here's rectangle, here's the constructor for circle, and it's complaining about all of these constructors for derived classes. It says, I'm sorry, I can't construct a circle for you, because to construct a circle, I need to construct a shape. But the shape constructor is private. And recall, if something is private, it's even private to members of the family. Other members of the family don't get to see private things in their base classes. If something is private to shape, rectangle can't see it. That means that if I need to call a shape constructor inside of rectangle, I'm forbidden. So this doesn't work. Just making the constructor of shape private doesn't quite work. But maybe you can see where I'm going with this. I have a third option. I don't want the constructor to be public because I don't want members of the public constructing shapes. But I could make the constructors protected. That means the only people that are allowed to construct shape objects are members of the same family. If you're a rectangle or a square, you can construct a shape. You can call the shape constructor. Because if you're a rectangle, you need to call the shape constructor. But if you're a member of the general public, like I am in Maine, notice that this is the only compile error. If you're a member of the general public, you are not allowed to call the shape constructor. That means you can't create a shape. Okay, this actually seems to be a pretty tidy resolution. There's just one problem. These aren't the only constructors that I have to forbid. So how else can I create objects? Well, I can create objects with a default constructor. That's what I was trying to call on line 158. I can create objects with other constructors. That's what I could also try calling on line 158. What other ways are there to create objects? And they'll think back to the end of last week. There's also all of these other weird exotic constructors, like the copy constructor, the move constructor. And that means if I want to forbid people from creating shape objects, I also have to create copy constructors and then make those protected. And so I'll have to add a bunch of constructors that I didn't already have just because I want to forbid anybody else from using them. There's also notation to explicitly remove those constructors, but I still have to use it. I still need new notation to fully forbid people from making generic shapes. And there's a lot of notation, and it's easy to miss something. It's easy to forget to write a forbidden copy constructor. That's one reason why it might be worth learning a better way. A second reason is, if somebody comes along and they see protected constructors, it may not be obvious to them exactly why the constructors are protected. So I guess maybe they could see, okay, so the constructors are protected. That means only subclasses can construct shapes. I guess that means that if I want to construct a shape, I have to create a subclass. So I can construct a rectangle, I can construct a circle. If I wanted to, I could make a triangle class. Somebody reading this might be able to pick up on the fact that the shape constructors are protected because you're not supposed to create shapes. But it might not be obvious to the reader what it is they have to do to fulfill their end of the deal. Why is it that the shape constructors are private? What exactly is it about the shape class that's incomplete? Maybe they would figure out, oh yeah, the area, height, and width are all 0. But is it that obvious? And can you see how maybe a programmer looking at this, it may not be obvious to them exactly what part of the deal the shape class can't do itself. So wouldn't it be nice if we had a way of both explicitly indicating the shape class is abstract? So it is not complete. It should never be created. But at the same time, also indicating what exactly is missing, what you need to do to complete the shape class. And we have that option. And it's over here in Shapes 3. So over here in Shapes 3, I have the same basic idea. So down here on line, in this case, 159, I try and call the generic shape constructor. So I try and create this generic shape object. Let's try compiling it. And we'll notice I've already fixed the problem in this version. I get a bunch of errors, and the errors are actually referring, you notice the compiler even picks up on get area, get height, and get width, because we know those are the functions that the shape class is sort of missing. It makes no sense to ask for the area of a generic shape. And notice that the error it gives is the following virtual functions are pure. Pure, okay. Cannot declare variable s to be of abstract type shape. I mentioned earlier, the shape class isn't meant to stand on its own. It's abstract. Its job is to provide an abstraction, but it isn't able to implement the abstraction. I've used some feature, which I'll show you in a minute, that allows the compiler to pick up on that. The compiler knows now the shape class isn't meant to stand on its own. It's abstract. And so I think this is a feature worth learning, and I think it's also pretty simple. So in my circle class, I override the width, height, and area functions. I do the same thing in my rectangle class, and the square class inherits those overridden versions. But in my shape class, I have this notation. I define virtual functions for area, height, and width, and I use this strange equals 0, which is unique to this case. So I'm not actually assigning an int. This is just strange notation. I use this notation to tell the compiler, hi, a shape object needs to have these 3 functions, but I can't provide them right now. They're not available. I don't have an implementation that can be used by default. We call such functions pure virtual functions. Like other virtual functions, they can be overridden. But unlike other virtual functions, there is no implementation available in the base class. They must be overridden. If you implement a shape object, you are required to override these functions if you want your result to not be abstract. What I'm saying is, in a sense, these 3 functions are an abstraction only. Any shape must have get area, get height, and get width, but this shape doesn't. That means that if you would like to actually create an object of this type, you must define a subclass, pure virtual functions. And so what I do now is I define subclasses like rectangle that then override those functions. And that means that rectangle, once I've written that, rectangle is complete. It implements all of the abstraction required by shape. But the shape class is incomplete. It says, here are some functions that I need but cannot provide, which means you cannot create a class that does not provide these functions, including the shape class itself. Okay, so I'm going to go down to main and comment out the declaration of the shape object. And then we'll try compiling again. And we can see it works. And I run it, and it produces, I guess, what you could call predictable output. So the rectangle, circle, and square classes, I should get rid of my reference to triangle because it doesn't really exist. The rectangle, circle, and square classes all override these pure virtual functions. They provide the functionality that shape is missing. By listing the functions as being pure virtual, shape is saying something is missing, you need to provide it. When I implement the rectangle class, if I want people to create rectangles, I need to provide the get width, get height, and get area functions. Suppose that I don't. So I'm going to do that in the circle class because circle doesn't have any other descendants. Suppose that I refuse to implement get area in the circle class. If I do this, then, well, what do I inherit? I do inherit get area, but the get area that I inherit from the shape class is a pure virtual function. It doesn't really exist. It's just a placeholder. If I try compiling this, the compiler is going to have a problem. It's going to say, I'm sorry, you can't declare circles because circle is now an abstract type. There are things that the circle class is missing that are required. In particular, the getArea function in the shape class has not been implemented yet. You are welcome to make subclasses of shape that don't provide all of the functions, but they are then abstract classes themselves, and you can never create a variable of an abstract type. You can only create variables if they provide all of the things that are required. So to be clear, it's fine to define a circle class without the getArea function. But if you want to create instances of type circle, you have to define all of those pure virtual functions. Because if you don't, if I had an object that didn't define get width, get height, get area, if I were able to have a shape object and I called the function, what would I get? It doesn't make any sense. The function doesn't exist. It's just a placeholder. So I now remove that and I try compiling again, and now I have it. So a pure virtual function is a good way of solving both problems. I can solve the problem of making sure that nobody can create the generic, incomplete, abstract class. And I can also make sure that anybody writing a subclass knows what their job is. In the previous example where I just made the constructors protected, sure, you can't make a shape object. But if you're making a subclass of shape, you may not know what the contract is. You may not know what you are required to do. With pure virtual functions, I can explicitly require that first, you can't create shapes yourself, and second, if you're going to make a subclass, you need to provide all three of these things. That is required.